Thanks everybody for coming. I hope you all have enjoyed the conference. Like I said, I promise I won't try to bore you guys to death at the end of the day here. I'm going to talk a little bit about the how and why of Chef on RightScale. The title is the how and why of Chef on RightScale. So I'm going to get started first with sort of the how, right? And there's a few things that are a little bit different about the way that we do things. I'm going to tell you how you get Chef code from your development environment where you're writing your code and getting it into RightScale so that we can use it and we can start putting together templates of servers that you're gonna configure and set up with Chef. Talk a little bit about Chef bootstrapping, sort of how we get Chef on the running virtual machines so that you can actually be able to execute Chef and kind of compile that code and converge your systems. I'm going to talk about how that code gets delivered to your instances and then how it actually runs. So the first piece of that is, you're working with your code, probably on your local machine, you're using your favorite IDE, maybe doing some testing, that sort of thing. You've got to get your Chef code from your system, from your development workflow into RightScale somehow, right? We offer 3 different ways that you can do that. Either using Subversion or Git, you can point to a specific repository, and I've shown an example here on the right of doing that with Git. That's actually how all of our server templates, RightScale server templates that we build in our engineering group, we use Git for storing all that code. You can also pull it from a URL that's at the, a zip file that's at the end of a URL. That can be handy if you have actually built a good continuous integration or dev test and build automation for your Chef code. You can actually have it where when you commit stuff to code, commit stuff to a code repository, it'll actually pick out those that commit and all the code from your repository, execute some unit tests on it, and then at the end actually build a zip file that you go and put somewhere, and we can pull that in. So that's one way to approach it. The next piece is Chef bootstrapping, right? So in order to be able to execute your Chef code, you've got to have Chef. You've got to have the Chef binaries on your VM in order to actually execute that code. Normally, what you would do if you were using a normal Chef server client, or even if you were potentially using the ops code managed solution for Chef, you'd run a knife command, a command line tool that will actually bootstrap that particular instance. And it's going to put, the right version of Ruby on it. It's going to lay down Chef. It's going to do all that magic to get that environment ready to go to actually start doing some Chef convergence. What's kind of cool with doing Chef in RightScale is that we actually bake that into all of the base underlying operating system images that we create. So in every single one of the clouds that we support, we actually pre-build an image that's that base operating system plus basically the latest security patches for the OS and a version of our RightLink agent, which I'll talk a little bit about as we go a little bit further on. And inside of RightLink is actually the Chef gem and the correct version of Ruby and all that sort of stuff. So it's as easy as going to our MultiCloud marketplace, clicking the import button there, and you've essentially bootstrapped Chef because you've already got an image that's got that stuff in there. So I already kind of alluded to it, but what RightLink basically is, it's a very simple, lightweight Ruby-based agent, so it's all written in Ruby. It's open source, so if you go to github.com/RightScale/RightLink, you'll see all the code for it. There's no secrets there. We want you to know what's running on your virtual machines. We want you to be able to see it and modify it if you need to. It does work on either Windows or Linux because we're using Ruby and because we're conscious of the fact that folks are wanting to maintain and manage infrastructure that's running a mix of environments and operating systems. It sandboxes the Ruby that it uses. So right now in version 5.7, we're using Ruby 1.8.7. In the next version, which will actually be released later this month with some of our new images, It'll be used in Ruby 1.9.3 and some newer versions of gems and so forth. So what's cool about that, the fact that we're actually sandboxing the Ruby and sandboxing the Chef gems, is that it's not going to interfere with your system. So if you're running a Ruby on Rails server, for instance, you can install whatever version of Ruby you need, whatever set of gems you need, and it's not going to interfere with our ability to run that agent and do the automation that we do. A little bit about how it talks to RightScale. So when that server comes up, we've actually, with various different cloud providers, found different mechanisms that are either built in or worked with them to actually build some sort of mechanism to pass in some unique identifiers to that instance when we launch it. So in Amazon, it's real straightforward. It's the user data. We pass in an authentication token, unique ID, some other things of that nature. With other clouds, we've had to do some novel things. We recently integrated with SoftLayer, and they actually built some functionality for us so that we could pass in metadata and do the same kind of thing. So what RightLink then does is it takes that information, dials back into the RightScale system and says, hey, I'm that new virtual machine that you asked for. And it does that over HTTPS, and then it opens up actually a persistent socket over AMQP. So we can basically push messages down to it so that over its lifetime, we can ask it to run scripts to update things, reconverge Chef run lists, that sort of thing. So that's sort of how we get that there. RightLink's also responsible for doing all the transactions of actually getting that code that we pushed into that backend system that we call Repose. So you take your code in from your favorite version control or from a URL, and it goes into Repose. And then when that virtual machine comes up, RightLink actually gets the response back from the server that this is the list of Chef recipes or write scripts that you're going to run, and it pushes those down to the instance through that connection that RightLink opens up. And then RightLink actually does all the hard work of actually taking that code and compiling it and executing it. So this is sort of a high-level abstraction of effectively what it does. It makes that call to the RightScale backend system. Backend system sends a list of these are the recipes you're going to run. This is the list of inputs and values that are going to get passed in. And it goes ahead and it actually, rather than making like a command line call to Chef, which would be kind of what you would normally do if you were maybe running it locally on a box or if you were doing it through Knife, because we're running a Ruby agent, we actually create an object that is right from the Chef gem. We take the Chef solo object, we create an instance of it, we pass some information into it. So you'll see in a couple slides here that we have the ability to excuse me, we have the ability to pass in inputs. So any value that you want to pass into your Chef recipe so it knows things about its context or the name of the database server it's going to connect to, things of that nature that you might use in your recipe, you can pass that in through the dashboard. So we actually go ahead and pass that in when RightLink goes ahead and instantiates that Chef solo object. We also have a set of custom Chef resources that we add to that runtime. It's for things like discovering other servers that are in the same deployment of servers, for being able to actually ask another server to execute one or many recipes, which is really cool, and just kind of the ability to do some of those tasks that are unique to RightScale. So we've got some custom resources that we add. And then lastly, of course, it presses the go button and actually converges all that Chef code. So I'm going to touch now on sort of some of the few little differences between sort of the RightScale implementation of Chef. I just mentioned or kind of revealed that we're using Chef solo for this. So we're not using a Chef client that talks to a Chef server and uses all of that API interaction to do the Chef converge. Instead, we're basically getting all the code together, getting all the metadata together, and then doing it as a kind of one-off execution with Chef solo. So in doing that, Chef solo doesn't support certain features of the ops code Chef implementation when you're doing Chef server client. One of those things is the concept of a role, and for those of you that have used Chef, you might be familiar with this. what a role effectively is a list of recipes that you're going to run in a specific order. Has a name, has a description, has all that stuff. It may be a little hard to read, but this is a role definition over here, right? It also has some inputs that are defaulted, some attributes that are defaulted that you can actually override even further on a specific machine. So the way we do this in RightScale is what we've always sort of done even before our Chef integration, which is we have what we call a server template. And a server template defines, first of all, that base underlying operating system image that we're going to use. And then it also defines this list of scripts that it's going to run. So this is kind of the mapping here, right? So here's the whole role definition. This role defines this run list of these recipes. And then in RightScale, we basically are doing the exact same thing with the UI and listing those recipes that we're going to run here. If you can read it, these are actually literally the exact same recipes in both places. So I mentioned earlier that the other thing that you add to a role is a list of attributes that you're going to default. So these are inputs that, you know, those recipes that are going to run are actually going to use to know things about its environment, know things about, you know, database host names. In this case, we're overriding some things like where we're going to put our swap file. Our time zone is set to UTC. We've enabled IP tables firewall rules, that sort of thing, right? So again, we're giving you that same functionality in the RightScale dashboard and in a server template by setting these inputs here. It's kind of cut off. There's all the same inputs here. I didn't have room on the slide for all of it, but you have all the same inputs there, but there's kind of a lot of other options that you can do there. We even have the ability to have what we call credentials, which are actually, you know, a value that you can grab from a drop-down and it just has a name. The user never knows what that actual value is. So you put things like database passwords in there, you know, administrator passwords, things that you don't want your user to know, but that they need to do their job. If I'm going to launch a new application server, I need to know the database password so that my application can connect to the database. You don't really want to hand those credentials over to users, but by using the RightScale dashboard, you can securely store them in the RightScale dashboard and let them pass that into their code without ever knowing what the actual value is. So the other piece of a role is really that, you know, that boot run list, which I already showed you here up at the top. So of course we do that. When the instance first comes up, we run this list of scripts on boot to configure the server. We also have two other kinds of run lists. The first one here, or the second one listed, is operational scripts. So what we can actually do is we can define that certain recipes might be run just a single recipe with specific inputs at any time on this server. So it's operational tasks, administrative tasks, things that your level 1 support guys might do, might SSH into a box and actually do that task. Instead, you can actually have them go to the RightScale dashboard and click a button that runs that same script. And then the third type here, we don't actually have any listed, but the third sort of run list here is decommission scripts. So any chef recipes that would be listed here would be executed anytime that a server is being terminated. So you think about an environment where you're doing cloud computing, you're in that really elastic environment where you're adding and removing servers, maybe scaling according to a load that's coming into your application. There's certain things you do when you're setting it up. You might add a server to a load balancer or something of that nature. That's going to go in the boot scripts. But there's kind of the converse of that that you're going to want to do when you terminate the server. You're going to want to pull it out of the load balance pool. You're going to want to close some of the IP table firewalls rules that you opened in other servers in the same deployment. So the decommission scripts, that run list is the opportunity to pull out those changes that you've done. So that's the how, that's sort of the nuts and bolts. And I'll stop for a second and make sure that I get any questions answered if anybody has any questions. Yeah, so it's an excellent question. I'll repeat it. So the question is, are we kind of concerned about that external dependency of having to depend upon a URL or a Subversion repository or a Git repository? So no, we're not, because I didn't reveal that we're actually caching anything that we pull in. That comes a little bit later, and I'll talk about that a little bit. So we pull that in one time, and then we cache it. And like I said, I'll get to the real details of it. It's actually towards the bottom of Chef at Scale, but we're actually caching that and distributing it and doing all sorts of stuff like that. So the question is, the distributed via a content delivery network, which is on this slide here. The question is if that's sort of inherent in Chef. It's not. That's actually unique to our implementation. So we'll talk about that a little bit more too. Sure. Yeah. So the question is, if you really have to know Ruby in order to do Chef, the real answer is no. The Chef language is its own DSL. It's based on Ruby, and the underlying execution is Ruby. But you really don't need to know Ruby in order to do it well. It helps if you're doing really hardcore stuff, but it's really not necessary. Thanks for that from the back. There's actually some tutorials on the ops code wiki, I believe, that has that. Basically enough Ruby to be dangerous, enough to know in order to do Chef. You'll run into things like what a hash notation looks like. You're going to need to know that probably, how to do a loop, those sorts of things. But it's real basic stuff. So we'll get into sort of the why. I kind of gave you the nuts and bolts. That's how it works. But this is why we kind of have done some of the things that we've done with Chef, and why you'd actually want to choose to use Chef kind of in conjunction with RightScale. So the first piece is Chef is really, really good at configuration management. It's the reason that we included it. It's the reason that we chose to use it, aside from the fact that it's open source and it was easy for us to integrate. It's not our core competency to do configuration management. It is our core competency to do things like multi-cloud provisioning, monitoring and automation, and kind of giving servers this contextual knowledge about the deployment that they're in. And I'll touch on each of those in a little bit as well. The other piece is that you can absolutely scale Chef if you're doing Chef Server Client. Opscode does it all the time. They've got a great managed solution where you can actually pay them, a monthly fee to run it for you, and it's hugely scalable. It's multi-tenant, and there are lots of folks out there using it. However, it is not easy to do that, and you want to have somebody that's actually solved that problem for you. It might be ops code, it might be our implementation. I'll talk a little bit about how we've done it, and we'll get into that. So the first piece of that is really multi-cloud provisioning and API aggregation. So what we do at RightScale is really abstracting the differences between those clouds that we support. So you think of even AWS, every single region of AWS is effectively its own cloud. It has a separate API endpoint. Any sort of object, image, data that you might put in an EBS snapshot, that sort of thing, is all homed to that region. You can't get it out, at least not easily. So we actually maintain, as I mentioned, these operating system images that has RightLink and has Chef built into it. And we have to actually build a separate one for every single cloud that we support. We make them the same in that they're the same version of the operating system with the same set of patches and the same stuff built into it. So it's a known base, but it's really different binary images on every single cloud. The other thing that we do is that once we've got that base operating system, we still have to kind of solve the problem of actually how do you provision this image into a running virtual machine on each one of these clouds. They all have different API endpoints. Many of them have different API interfaces, so the call is different, and you've got to select the right image, do all that stuff. So we do that, right? We make that really, really easy for you. So Chef has Knife, which is awesome, and you can actually provision stuff in the command line, but you've got to know the image ID you want to launch, and you got to hope that it's the same in different regions. You can specify a different cloud, but that's going to require different parameters. So you kind of have to have this knowledge in your head. We basically make it easy for you to just point and shoot. I want this cloud. It'll ask you a few questions, and you're good to go. And I forgot to mention, we actually expose all this stuff through a unified API. So we have one API that you can call to provision on any one of those clouds that we support. The other piece is monitoring. So we maintain a full backend of servers that'll pull in monitoring data. The way we actually configure that is by installing and then configuring a monitoring tool called collectd. And it's fairly simple but very mature open source project for doing monitoring. Anything that you can imagine on an instance, we can pull in that data. So I've got a couple examples here of, this is from a running database instance. And these are just all the monitors that are available just for MySQL. There's all sorts of different plugins that you can install. This one's running the MySQL plugin. That's why we have all these monitors. There's ones for Apache and Nginx and HA proxy and pretty much anything you can imagine. And again, it's open source, so you can extend it. And in fact, this down here, you might have seen that in our keynote, is actually what we call a stacked graph. And this is something that RightScale actually sort of invented and extended the collectd product or the collectd project in order to actually have this sort of thing in it. It wasn't normally there. So what we're doing is aggregating a single thing, which is Apache requests per second, and putting several servers on the same graph. So it just speaks to how it's open source, and it's really useful to do that. So what we do with that monitoring data is not just pull it in and show you pretty graphs, which are kind of cool to look at, but we can actually take a look at any one of those metrics and do stuff based on thresholds set on those things. So this is from our dashboard, a list of alerts that are pre-built and put in here. This is actually from the XenServer server template that you can actually import from the library. A lot of those are predefined. So on a XenServer, we want to make sure that a PHP server that Apache is running. If it's not, we probably have a problem. So we've got to check for that. And the escalation is that we send it to an alert queue called critical, which basically, depending on your configuration, can do anything. But by default, it'll send emails on a real short cadence every 5 minutes. Make sure that you know that this is happening. And then these top two are specific to sort of the automation pieces that we do and that we really do really well at RightScale, which is being able to scale up and down an array or a tier of your server's application tier. So the actions you can do, I mentioned email. You can also execute a script on the server that has the condition that you're looking at, or any other server that's in the same deployment of servers. You can reboot the server, you can relaunch it to actually terminate it and bring up a new one, or you can do what's represented by these two, which is you can actually vote to increase or decrease the number of servers that are in a particular tier of your application. So it's actually important that it's a voting mechanism rather than a server that just unilaterally runs a script and, hey, I'm under distress, so therefore I'm going to start adding some more servers to the deployment. It might be a red herring. That one server might have a particular problem. It might have hit a corner case in your code. It might not have connectivity to the database for whatever reason. And that one server is in panic mode, whereas the 5 other that are running in your application tier are just fine. So you don't want that one actually adding a bunch of servers. You want to make sure that all the servers kind of have the same condition. We make the decisions based on that. So the other piece of this that I mentioned briefly is that, and you guys probably can't read this, but I will talk you through it. This is sort of just the server screen of a deployment. So this is a whole 3-tier architecture. It's a pair of load balancers, a master-slave database pair, and then a single application server running up here at the top. So what you would do if you're launching new servers into this, if you want to automate the whole process, you got to make sure that that app server knows about the environment it's in. It has to know that when it comes up, it has 2 load balancers that it has to connect to. It has to know that this is the IP address of the database server and I can connect to it, and I know the username and password to use because I've passed that in as inputs to the RightScale dashboard. All that stuff is there. So the way that we do that and the way that we let that one server know about the other servers that are in the same deployment is by using our backend and leveraging the RightLink that's running on each one of those servers as well. So when this application server comes up, after it's downloaded your application code, after it's set up a config file for the database and sort of done all the stuff so that your app can start accepting requests, it uses the RightScale backend to do a query to find the load balancers. It knows it's going to be in a load balance configuration because that's part of the server template. And it actually looks for any server in the same deployment that has a specific tag. Load balancer equals my listener. And then you'll note that up here, it's actually identifying itself as an application server for that particular load balance pool. So it detects those two load balancers, and then it's actually able to remotely tell those load balancers, hey, I'm a new application server. This is actually what the Ruby code looks like. And this right here is one of those custom resources that we add to the Chef Solo run, which is called remote recipe. Basically says, I want to remotely execute this recipe name, LB handle attach, and this is the inputs I'm going to pass to it, and I'm going to send it to everybody that has this tag, and we're assembling it based on the name of the load balance pool. So what this does is it makes a request from that one application server that's come up to the RightScale backend system through RightLink. The RightScale backend system says, okay, I know that there are two servers that have this tag with this name. I'm going to send a request down to that server to execute this recipe named LB do, or I think it's just handle attach in this case. And that happens almost instantaneously. This is the audit entry that pops up in the dashboard of the load balancer, basically getting that request, getting the inputs for that, executing that code, and now your application server is in that load balance pool. Now, if you were to do this maybe in a more traditional model where you didn't have all that orchestration in between, what you would do is your load balancer would be constantly converging Chef. So you can set it up with the Chef client daemon, and it would run every X number of minutes. You can set the cadence, right? What that would do is it would then do a search for all the nodes that are registered with the Chef server. So every time a new virtual machine comes up and it's converged by Chef, it sends a bunch of data to the Chef server and kind of announces itself and makes sure that all the data is there. The load balancer is going to then do a search, find servers that are tagged, and then add those by their IP address. That works perfectly well. The problem is you have to wait for that window of time before the load balancer reconverges. So it could be 2 minutes or 5 minutes or 10 minutes or 15 minutes. And if you're in a panic mode where you gotta be scaling out a bunch of servers, you can't wait that long. And that's why we implemented it the way that we did. Is you can still do it that way where the load balancer discovers all the app servers and adds it, but you can also do it much more proactively rather than reactively by actually explicitly making the load balancer run that recipe. All right, so that's sort of the why on some of the little differences between Chef on RightScale and Chef from Ops Code. I'm going to touch a little bit on Chef at scale. So we talked about Repose, which is sort of that back-end cache of all of the code that you're pulling in from your source code repositories or from a URL. So what's interesting about Repose is it's not just this big blob. In fact, it's a distributed system. So you don't have just one big single point of failure that is Repose, that if it went down, you wouldn't be able to get code from it. It's many different servers. And in fact, not only that, but it's distributed across different clouds. In fact, we actually use Amazon's CloudFront to do some of the distribution of that code. So we have it replicated in endpoints that are all over the world, real close to the VMs that you're launching. So what that means is, of course, it's duplicated in a lot of places. There's no chance that it won't be available when you actually go to execute your Chef converge. So, that's kind of the idea here. It's for two reasons. One, it's to make sure that that code is always available, right? We were caching it to begin with, but now we're not only caching it in our own systems, but we're also pushing it out to that content delivery network. So it's super reliable, super available. And it also makes it really fast for when you're converging servers to be able to pull that code down.